Cool. Well, how's everyone doing today? Doing good? Yeah? Nice casual Saturday. Relaxed. So last time I taught this course, we were teaching it in Raleigh, like downtown Raleigh. And it was just like last fall or whatever. And I swear, every other weekend there was some sort of march or protest or like parade going through right behind us, and nobody could find, like, it was just crazy. So it's a lot nicer to be here in Durham where there's just not much going on Saturday morning right now. It's not insane. And you know, for those of you who have longer drives, I'm sure it's nicer to get here, as we were already talking about, on Saturday than it is on Tuesday. Awesome. Well then, let's go ahead and do a quick review to start off with. And then after we review some of the stuff, we just have a couple new concepts. Class might be a little shorter than normal today. It depends on how long some of the review takes or how deep we go into some of these concepts. But then we'll have probably more exercises for you to work on after class than we've had previously. So the first thing, I just wanted to review some basic, let's go over some code that the first couple should be pretty simple for you, not too complex. And the first one is definitely one that you should have been able to know for sort of a couple classes now. So let's look at this program down at the bottom that we've got here. What is the output of this program that we've got right here? Var a equals 1, b equals the string days, and then this console log statement. Anybody want to take a guess at sort of what the output for that is?
Which one? What is that?
The one you see right at the bottom of the screen right now. So var 4 days. Yeah. All right. Let's run it real fast just to check. Sure enough, that's what it says. So let's step through it just to get, we won't do this for most of the programs that we write, but especially these first few weeks, I want to step through these programs line by line so we can think about them and ingrain in us what's going on, right? So in this first line, we're just we're declaring the variable a, and after we declare it, we're assigning the value 1 to it. That's actually 2 separate steps. Previously to today, you've always done that as one step. You'll see how those can be separate today. And then we are declaring the variable b, or defining it, if you will, and assigning the value days as a string to it. And in the console.log statement, if we break it down, it sort of works problems from the inside out. So here it looks at a and it says, okay, what do I have for a? Well, that's 1. So 1 plus 3, that's 4 as a number. It also then looks at this b. B is the string days, so go ahead and replace that with days. So now if you're reading this line, it looks like console.log 4 plus a space plus days. And we already know that if you add a number to a string using the plus symbol, it concatenates it all together and converts that number into a string instead. So it converts that 4 to a string, and we get 4 space days, and that's how that breaks down. So when you're looking at code, again, if you're ever wondering why something isn't working or a little puzzled by it, try and break it down piece by piece, step through every bit of the logic, because it'll really help you find what's going on and what's wrong. So let's look at one that requires a little bit of what we learned last time. We'll review some of the material we learned last time as well right after we go through this, but this one's got a nice comparison operator in there. How about somebody else want to take a guess at what the output for this one is? Can you read it? All right, just making sure. It's a little hard for me to tell from my angle.
So it would be and 11 is less than or equal to 10 in this case. So it would be, it's a Boolean, so it would return false, right?
All right. I like how you broke it down, right? You hear him sort of step through that. Is he broke it down to 11. Oops. That's not the right way to bring up my console here. And if you look at the output there, you can see we get back false. Sure enough, when we evaluate the console line, because you have 10 plus 1 is 11, and then 11 minus 1 is 10. So 11 is less than or equal to 10. It's not true, and it's false. And you get the Boolean back. So I have one more, and this one's just a little more complicated. Not too bad. I'm actually going to put it into a Scratch area because we might run a few different versions of it instead of just one bit. So we can look at it over here in this Scratch space. So after looking at this for a little while, does somebody want to take a stab at what the output of this program is? Oops. Keep doing that.
So you print out the first console log, the answer to that.
Any other guesses? Mario? You're not sure?
So I don't know what this. Where would 42 fit in? If it's a number? If it's number is a variable, right?
Yeah. Number is a variable holding the number 42. It's a little confusing to say that, but it's holding the number value 42.
I try for an error because the equal sign, the comparison is, between a number and a string in this case because it's between quote. So I think it will draw that.
It's a good guess. So let's go ahead and run it real fast. Okay, so it prints out both. So it looks here and it says, all right, the number 42. That's equivalent to the string 42. So go ahead and run the code inside of this if block. And then it continues on after that and runs the rest of the program, which is the other console log. So let's go ahead and play with this a little bit. There was some confusion over what it would do. Let's try some different options here instead. If people remember, there was a difference between double equals and triple equals in class. Anybody remember what that difference was? Double equals versus triple equals?
Double equal is pairs type of.
Yeah, I mean, they both are Boolean type comparisons, but the triple equals requires the type to be the same as well. So does anyone want to take a guess at what the output will be now that we change this from a double equals to a triple equals?
I remember if you put triple, it's not going to give the answer anymore, I think.
So you think we're only going to see the second console log?
Yeah, false, like.
All right. Exactly what happened. Can anyone explain why that's the case? It's getting close to what you were trying to think of. You're right, they were different types before. I mean, However, JavaScript will implicitly convert types if it can. To compare two things of a different type, especially with double equals, it will do that. But triple equals says these have to be the exact same type. Don't convert my type at all.
So it's more like explicit.
Yeah, it's more explicit. It's stricter, if you will. Now, it won't produce an error because all it's doing is saying, is this item the same as this item? It's just looking at two things. You know, it's looking at these two things right here and saying, are these the same thing? And in one case, it's a little bit like, I don't even know how to describe this. Like, imagine if I had sort of like a drawing of this adapter. And when it's doing type coercion, it's almost like it's looking at it and going, oh yeah, that drawing, that's the same thing as what you drew. You know, they're equivalent, but in the other case, they have to be the exact same type of object. They actually have to be this adapter. They can't be, you know, converted over to it or implicitly thought of as being the same thing. And so that's why we get a different result when we do that. So now let's try this. So triple equals and the number 42. What do you think the output's going to be if we run this code?
It should be the same. I don't know why.
It should be the same as?
Sprinting the answer to life the universe.
All right. Has anybody here read Hitchhiker's Guide to the Galaxy? Nobody gets the reference? Ugh, I feel so geeky. Yeah, it does. And that's because this time, when it compares them, it says they're the same type. So that means I can compare the values, and then it compares 42 to 42, and those are the same. So it goes ahead and prints it out. So let's change this one more time. I changed my value of number in the program. So what's the output going to be this time around?
Just the console out in the if statement.
Just the second one. Okay. Does that make sense to people? Are people sort of comfortable with that concept? Why that code worked the way it did in the different ways that we wrote it? Okay. So let's step back here real fast. Let's continue the review. I don't have specific examples already written out, but we can step through them if anyone wants to for these other types of comparison operators. But first, let's walk through them. Let's sort of go around here. Not going to get everyone's name right, but I'm still working on it. I'm getting better. So Mario, I do have this first operator, this double equals. What does that comparison operator do? Can you explain that?
It's I don't remember that.
You remember that one? Okay. That's just comparing two things, but it will convert type if it can. So it's seeing if two things are the same, but it's willing to convert the type. Now, Alex, what about the triple equals? What?
It doesn't give you like that equal value of it. It's just like comparison.
Okay, yeah, between two things of the same type. Yep. It's a good explanation. I think these ones are relatively greater than, less than. I feel like people are more comfortable with some of that stuff, so I'm going to skip over those real fast. It's Casey, right? All right, what about this exclamation mark equals sign? What is that? Not equal to. But it'll do type coercion. It'll convert the type if it can. Yeah, that's down here. Yep. Okay, and I don't have your name. What's your name? Karen. Yeah. Man. Okay, Karen. What about this exclamation mark and the double equals sign? Yeah, that's a good way to think about it. An exclamation means not, in a sense, and so it's sort of saying like, are these things equal? Not. So it sort of flips the equation, which is the same thing that this exclamation mark and one equals sign does, except the double equals. Can you say what the difference between the two is? That's the type coercion item again. So if we're looking at that in code again, if we have 42 does not equal 42, that's false because it thinks that they're the same because it converted the type. We do it here, it says that it's true, and that's because it looked at the two, it said, all right, I have a number and a string, so those aren't equal to each other, which means that this statement is true. Or if you wanted to break it down, you can say, is 42 equal to 42 the string, and are they the same type? The answer is no. So then you can negate that, flip that around, and you get true, right? Okay. Me and names. Dave. All right. It's easy. All right, I won't forget. So how about this this ampersand ampersand? Can you explain how that one?
Which one is it?
What that one does? Ampersand ampersand, right here.
Oh, this is the and. We compare to, well, it's combining two comparisons.
Okay.
It's a Boolean.
Yeah, it's comparing two Boolean
We
values.
compare two values. I mean, when we combine two values or two expressions, let's say.
Right.
We say 11 plus 10 is equal 20, and 9 plus 11 equals 20. That's true.
Okay. Yeah. It's comparing two, and it only returns true itself if both of the items it's looking at are true. So that's how AND works. If both things are true, then it's true as well. Right, Axel. What about these are usually, a lot of times these are called like pipes in programming. So you may hear me use some of this terminology, vertical line, but pipe is a pretty common term. So what about this like pipe or?
Is it like, they say like A is less than this or B is less than that?
Yeah, it's a good way to think about it. I try and, when I'm thinking about them, I try and minimize it to just the most basic, which is why, for example, when we were showing the comparisons, I was just using the direct like Boolean values for it, as opposed to filling stuff in. But the important part is it breaks it, it works the problem down until you get to these sort of Boolean type comparisons of the values. So yeah, if you had like exactly what you were saying, var A equals 3 and var B equals 5, and then if we did A is greater than 3 or B is greater than 4, for example, that's a more complex version of it, but it's doing the same thing where it's looking at each side and breaking it down. So A is not greater than 3 because A is 3. So that's false, but then B is 5. 5 is greater than 4. The other side's true, so that whole or statement's true. Does that make sense for people? Yeah? this type of logic, these are like the underpinnings of programming. You're going to do a ton of logic around this. And it's because what we added, we already looked at one example or whatever. We added these if statements, this control flow, if you will. So the first couple classes, we wrote programs that just walked right through the code, just line by line, running the code. Every line in the code ran. It's very easy. It's like you're reading a book, right? When you read a book, you read every line in the book. Unless, did anyone here read Choose Your Own Adventure books? No? Only me? Oh man, I feel so old. All right. Nobody read a Choose Your Own Adventure book. These are the books where you might be reading, and then at the end of a page it says, if you want them to go into the cave, go to page 50. But if you want them to instead go around the cave, go to page 70. And so the book would go down different routes depending on what you chose. And that's what's going on with our code now that we've added in some of this control flow logic, if being the most basic piece of control flow. And we're going to see another bit of control flow logic today, which is looping. And that allows you to change the execution of the code. So it doesn't just go through line by line by line, but it will skip over pieces or jump around or even rerun bits of code. And that's how you can build really, really complex applications. Because you can imagine if it would be impossible for them to write Windows, for example, or even just something very simple. Let's have a simple number comparison game. It would be impossible to write that if it had to, every line of code had to be written out directly. If somebody chose a number and you were trying to see if that number matched, the number that the computer had, you wouldn't necessarily be able to do that unless you had a way to logically go down different paths. So that's the start of what if and else statements do. And then, like I say, we'll introduce another control flow logic today. And I did see a tiny bit of confusion around if else. So I want to let's go with a slightly more example here, more complex example, if you will, to show some of the behavior and what you can do with some of this stuff. So we have our if statement here, which is pretty basic, and I've already done else. You can, when you're writing an if else, you can write the else on the same line, or you can put it on the next line, whatever you prefer. It doesn't make a difference. However, when you're working with these, one important aspect is making sure that your opening brackets and your closing brackets match up. So you need to have as many opening brackets. Each time you open a block, which is what a bracket, these brackets defined in JavaScript is a block of code. Each time you open a block of code, you need to close that block of code as well. So in this case, we've got like if, else. So inside of our else, let's nest another if statement. Let's go ahead and put something else up here, just to add some more complexity to this. Let's put another if statement in here, and let's say if hello equals goodbye. You might notice I already have a bug in my code. I did a single equals instead of like a double equals. Hello equals goodbye. And you can even see this. My editor's trying to sort of yell at me saying, hey, I expect something here. But if I put an opening brace there for this if statement, let's make sure this actually runs. So I'll change it to this. Boring old hello world. So I'm going to try and run this real fast.
Is there a reason why you did single quotes?
It doesn't matter in JavaScript for the most part. Some programming languages, it matters. I do it because I don't have to hold shift. So it's a habit for me to do them, and I'm trying to use just double quotes for you guys so I'm not changing around too much. But out of habit, I do it because I don't have to hold shift when I type it. The drawback to single quotes is if I did have, like, say, don't in here, I have to do something special to escape the apostrophe there because it doesn't know the difference between that and a quote, a single quote.
And then you left that bracket in the second if statement open.
Yep. We already jumped ahead. I wanted to show, okay, this is going to complain to me about something. And it's yelling at me, so let's sort of step through this. It says, oh, there's something wrong in this Scratch.js file on line 10. That's what that :10 at the end of this is. So if we look at this, we say, wait a minute, there's not even a line 10 in this program. What does it mean there's something wrong? And it's a little hard in this case to understand exactly what it's trying to complain about. So it's not going to be the easiest one, but luckily I also have this helper, at least in my editing environment, that's sort of helping me out. And it's telling me, hey, I expected another curly brace. And that's because, let's go ahead and try and look at our code. We have an opening else curly brace. So we opened, and then we opened the if statement. Oops, you can't see it right now because where my cursor is, with a curly brace. And then we closed the curly brace, but that means we're closing this if block. So we're not closing the else block. So we have a mismatch. We have a curly, we're missing closing one of our blocks of code. So if we just make sure, okay, I've closed that block of code. Now it should run correctly. But you notice this code didn't run either in my else block at all. Nothing in here ran. And why is it that the else block didn't run? Because else only runs in an if-else statement. Else only runs if the if isn't true. It's like you're making a choice. You're going down left or right. So if you don't go left, you went right. That's essentially what else is doing. And since 42 equals 42, it runs the if statement, but not the else portion at all. Now, if we change that, we make this 41, for example. Then it's going to run the else statement instead because the if wasn't true. Now what you can see here is we sort of nested. We put another if statement inside of this else block to have some additional logic. Now let's change it so instead we just do something. We don't really care about this world bit. Let's make this all the same. So now if it's not the answer, if number is less than 42, let's say something about that. Not quite there yet. Okay. So now we should see not quite there yet. What if we make this 43, for example? What's going to get output by our program right now?
It's comparing typos, so it's just right.
I changed my value to 43 up here. So let's walk through the code. If we have 43 equals 42, that's not true, right? So we go into our else. So now 43 is less than 42.
So even if you have a triple equal and it's doing typo, which is an integer versus an integer, it's still going to do the equals?
Yep.
Okay.
Yeah, it compares first it compares type and then it compares value,
so it
essentially.
Convert it, but if it's the same type, then it does the same.
Yes.
Okay.
Yep. There we go. Yeah, maybe I wasn't clear on some of that, but yeah, it does both. It has to both match the type and do the comparison correctly. So in this case now, what do you think is going to get output by the program? Not quite there yet? Oops. You get nothing. Yeah, because the number is also 43, which is larger than 42. So we have another case that we're missing. So what might we do to handle that case so that we're covering all of our options here? Yeah, we can put an else on this. Too far. Right? Now, does this cover every case, every possible case for the number? You can think of anytime you have an if and an else, you do cover, in a sense, every possible case, but it's either if or the else block. And now since we nested another if block inside of our else, this pointer does not work. Then at first we weren't covering every possible case because we just had the if inside of there, but now we have an else as well, which means that's also covering every possible case because it's either one or the other. So every case will, no matter what the value of number is, one of these three things is going to get output, and we've covered all possible cases for it. Does that make sense? All right. And you can also, this is a little cumbersome, a little awkward to write your code this way. I mean, nesting, by the way, I sort of glossed over a little bit, but indenting, whenever you're inside of a block, a practice, sort of a best practice, it's not a requirement of the programming language, is to indent all of the code. And that way, each block you go in, you indent again. And that's so that when you're walking through the code, you can just visually see where you're at, right? If I'm looking here, I can see that everything at this level is inside of this else block because it's indented a level. And then, oh, this is another level in, that must be inside another block of some kind. There's no requirement that you have to do that in JavaScript. Some programming languages care about white space. JavaScript doesn't care about that. It's a visual cue, but it's probably one of the most, I would say, I don't know anyone who doesn't follow this pattern. This is something that everyone uses because it's so helpful when you're stepping through code like this. Now, not everyone always puts their curly braces on the exact same line. That can vary. Like some people will do this. The curly brace doesn't have to start on the same line. Some people prefer it when they line up directly with each other. I usually put them on the same line as my if or else. That's just my convention. But the indentation, that is so useful that it's become a standard, and I don't know anyone who wouldn't use that in any code that they write. But as I was saying, this is a little cumbersome now, right? We've got this else block. It's sort of cumbersome to have to go in here and then do these if comparisons against this same value again to try and capture other possibilities for it. And so pretty much every programming language has given a way to make that a little easier, which is known as the else if. Change this just a little bit. And so what we've got here is really just a simplification of that if-else that we just wrote, the nested if-else. And the programming language has it built in where instead of having to nest it, we can have essentially multiple if type statements all chained together. And then it will walk through them one at a time until it finds the first one that matches and give you the result of evaluating that block. So if you have 42, it runs the if just like we're used to. If you put in 41, well, then the if isn't true, so it looks at the else if. That's true, so it evaluates that, and it's done. And if you put in 43 or something, the if isn't true, so it doesn't run it. The else if isn't true, so it doesn't run it. And then the else block, well, that'll catch everything because there's no condition to compare against, so that'll always run in that case. Does that make sense? It's just a really, really nice shorthand for nesting if statements. All right, it's mostly review of the material we covered last class with a little bit of explanation of this else if content. So the two major concepts I wanted to cover today, the new ones, are the idea of we've got two new types we're going to introduce. That's null and undefined. JavaScript in this sense is a little confusing in that it has both of these types. And then we're going to talk about looping as well. So before I go over new types, can anybody tell me what are the types that we've already learned about? We have, I believe, 3 types that we've learned about so far in JavaScript. Number, string, and Boolean. Yep, exactly. And those ones are, you can have a lot of different things in a sense that evaluate to those, There's a lot of possible numbers. There's a lot of strings, an infinite number of numbers, infinite number of strings. There's only 2 Booleans. There's true or false. Well, now we're going to introduce 2 new types as well, and those are null and undefined. So I'm just going to, before we try and explain what these are or go into depth, I'm going to try and just give some very basic code examples as we walk through stuff. Can everyone see this code, by the way? Is this large enough? All right. Because the best way to think about these at first is to, again, it's another one of those things just through repetition, because they're not concepts that make sense. They're a little bit like infinity or things like that. They're not something that is instantly understandable. So before, anytime we've defined a variable or declared a variable, we've always assigned a value to it at the same time. But now I'm going to declare the variable foo, but I didn't assign any value to it. And if I look at the type of foo now, we'll see that it says it's undefined. So what undefined means is just you haven't actually defined what's in me. I don't have a definition of any kind whatsoever. And undefined is also a primitive itself just directly in the language, so you can compare against it, like foo equals undefined. That's true because it's undefined is undefined. And then we also have, and this is where it's unfortunate for JavaScript because it would be better if there was only one of these concepts, not both. You also have something known as null. So this is an actual value that a variable has, but it's a little different. It's very similar to undefined, but just slightly different. And I'll try and give you some examples to help think through this. So if we did type of bar, this is where it's going to get very confusing. It tells us object. Thanks, JavaScript. I just told everyone that null is a type, but when I did type of, it told me object. I'm sorry to say this is sort of a bug in the language from the very first version of the language. It's now standard, and so they can't fix it. It should have returned null as the type of null, but it doesn't. Null is a type. You just don't get it back as a value off of the type of operator. But if we compared bar to null, that's true because it is null. So what's the difference between undefined and null? This is something I just somebody take a guess, because I don't think it makes any sense until you've got some examples or something like that. Anyone want to take a guess as to what the difference could be between them?
So null is a way to say that you can bring back a piece of data that has no data. For example, if you have a table where you have some cells that would be filled in and you want to pull the ones that are not filled in, they pull null and it'll pull those.
So you can map this pretty nicely over to your SQL experience, huh? Yeah, but it's this is why we're going to have a lot of examples of this. This is something you can't exactly explain immediately, but remember before we were looking at, like, if we had a section of memory and we have some values here, and over here we'll create some variables, foo and x and bar. So what's sort of going on, the difference between null and undefined in a sense is when I've created foo here, but I haven't pointed it at anything, then it sort of knows it exists, but it's not really allocating any space for it or doing anything with it. Now let's say I give foo, a value. So foo points to hello over here. And x gets a value. We're going to have x point to this memory location down here, which has 5 in it. All right. Now, what if I then change, or from some equation somewhere, I want foo to essentially point to nothing whatsoever. But you might think, well, I could do something like maybe create an empty string so that foo points to that. But that's still something. It's an empty string. It means that there's something there. So what could I do for it to say it sort of points to nothing? And the essential answer to that is you could just you have this thing that's not really a value to say, no, this points at nothing right now. There's no location, there's no value that this is pointing to that has any real meaning. It's a concept that's a little hard to get your hands on, but we'll go through a few more just rote things here. We'll have some more of these also in homework because it's best to refine them, and then I'll look at a couple funny examples that maybe will help reinforce that a little bit too. So let's keep stepping through some of this. Undefined equals undefined. What do you think the result is? Guesses? True? Anyone else?
True.
True? Yeah? All right, there we go. Let's talk up. Let's make this interactive. True. What about null triple equals null? True? Yeah? Okay. What about null equals undefined? False? Why do we think false? What?
They're different things.
They're different types.
Yeah.
Yeah, and triple equals does a type comparison first.
Yeah.
Before it even tries to compare the values. So it looks at null, undefined. It says these are two different types. I don't even care what the values are. That's going to be false. But now, what about null equals undefined? Any guesses? Yeah, go ahead and take a guess. What do you think it might be? Who thinks it would be true? No? Who thinks it would be false? All right. That one happens to be true. And that's because JavaScript, again, I said it's very confusing that it has both of these concepts. A lot of languages won't necessarily have both of these, but they're sort of similar. Undefined and null are somewhat related, and so it allows those two to be true when you're converting type. It says, these are about the same thing. I don't even have these in my work, and I don't even know what the answer to these are off the top of my head. Let's try null equals true. What do we think? False? Who thinks false? All right. Who thinks true? It's false. All right.
Because you didn't set true as a variable.
Well, it's comparing against a Boolean true. You can't use, I might go over that. There's certain words that you can't set as variables because they're reserved in the language. Any word that's like var, I couldn't do like var because it's a reserved word. The language has to have a way to know you mean something. Got myself all screwed up. The language has to have a way to know that this is a special keyword and it means something to it. So any of these keywords that we've learned can't be variable names directly.
Is there a name of that list of the types?
There is. Let me take a note to add that. All right. Yeah, because you'll definitely want that list. So what about null equals false? Who thinks this one's true? All right, who thinks this is false? So that's false. That's a little interesting. What about undefined equals true? Who thinks it's true? All right, who thinks it's false? Who just has no idea? Who's completely confused? Okay. About undefined equals false. You think that's true? That's still false. These are a little weird. I'm comparing them directly to them, but they are also, null and undefined are both false E, but you can't compare directly to false when you're doing something like that. All right, so we've looked at some of that. Now, what do we have in foo again? Foo is undefined. What about bar? Bar is null. What about foo double equals bar? True? Who thinks true? All right, who thinks false? It's true. We went over that. That's the type conversion because null equals undefined, right? Is true. And if we look at this, we have foo is undefined and bar is null. So it's essentially saying null equals undefined. But if we did foo triple equals bar, that's going to be false because they're not the same type again, right? It first checks type. It says, oh, these aren't the same type. This isn't true. So at this point, you're probably thoroughly confused. You're probably in this state. Let me see if I can find the... Probably like this right now. I have no idea what I'm doing. Yeah, but I'm a programmer. Yeah, don't worry about it. Everyone gets this way. This stuff is very confusing. It's not intuitive. It's not easy to learn or understand. So a couple, oh, okay, I need to put these on separate lines. A couple other examples, yes?
I have a question. If you are trying to use a variable that's defined in a function, how the function gonna react, or how the program is going to create gonna react to having a defined variable?
How is it going to react to having an undefined variable?
Yes.
So it depends. Let me come back to that in just a moment, and then we'll look at some possible routes there. So let's look at a couple other things that maybe offer a tiny bit of clarity around some of this. also just humorous. This is like somebody came up with this humorous example recently that's been going around in the past few months of the difference between 0 or like an empty string and null. So you can imagine this nice empty roll of toilet paper here. That's 0 for an empty string. There's nothing there, but it's like there's 0 value there. But this one that just doesn't even have the roll, that's null. Nothing is there. There's nothing to even know that it's empty or non-existent.
So that could be equivalent to define and null.
It's the equivalent to 0 and null. Yeah. Undefined is sort of magic. I don't think people really have good examples of that because undefined isn't used a lot in a sense, but
Can a variable be undefined and have a value? Or is undefined because it doesn't have any value?
what's that?
Can a variable be undefined and have a value?
That's a good question. So you can, like if we have foo, let's have bar. You can assign undefined into a variable to reset it to undefined, just like we did. Bar equals undefined. So now bar has the value like undefined, which is the same as it being undefined. It's a little weird.
But the undefined keyword in this case is a keyword for the Java program, for the
JavaScript, yes.
But let's say if you don't define the variable when you first declare, and then you use it and assign, let's say bar house, let's say equal house.
Okay, let's do foo because we already have had that. So now can we give it a value?
Okay.
Yeah, you can.
Now I understand the whole.
Yeah, undefined is essentially it's saying it's you have defined it in some sense. You've declared it, but you've never defined what it has at all. You've never given it an actual value of any kind.
I'm just trying to understand what the purpose of not defining a variable when you start writing.
Very rarely would you do it. In fact, a lot of code quality checkers will throw like a warning if you have a line like I did, like var foo. Like a lot of them will throw a warning on that line saying you should define this. Don't declare and not define at the same time. Give it assign something to it when you define it. You know, even if what you do is like I did, where you set it to null because you don't know what you want it to be. They're like, give it some value when you declare it.
I'm just trying to have a concept clear because in Java, you know, you create a variable, right? And you equal to put nothing. Let's say if a string, you could put nothing, just the two, right?
Right.
And then later on in the program, you can assign a value to that variable and use it.
Yeah.
In JavaScript, it's the same.
Yeah, it's the same. You can do that. Yeah. Yep. And you can also, so you were asking about, you know, some of that stuff and what happens if you try and use something that hasn't been defined at all. Well, there's sort of a couple. The most common thing is if you've sort of declared it, like we've declared foo. Let's put that back to undefined. So foo is declared, but it doesn't really have a value at all, not even null right now. So if I had a bit of code, if do not foo, console.log, hello. You can see that it went ahead and ran that line, but now let's use something that really doesn't exist at all, if not blah. And there's a difference there because I never did like a var blah. Like I never said, here's some sort of variable name that you might use. So the code instead threw an error. It said, blah isn't defined. You never defined this at all. You didn't even define it so I can have undefined. I can't work with this. So that's sort of the difference between the two. Now, it gets a little confusing if you did like type of. Because if I did type of foo, I get undefined as I expected. But if I did type of blah, it also says undefined because it's sort of looking and going like, there's nothing here. I don't. This also doesn't have anything. So it's a little confusing in some cases.
It's good to understand those codes really early because later on we have 300 lines of code trying to find you know.
You're going to run across null and undefined all the time in JavaScript, and so yeah, you need to. You can usually treat them as the same, but not all of the time. And I also think this is pretty funny.
It's all there, black and white, clear as crystal. You get nothing. You lose. Good day, sir.
That's what I think of when I think of null. You get nothing. Like not even zero, you get nothing. So yeah, again, these are like the concepts of infinity or anything like that you've encountered. They're not something that's easy to internalize or something that you just sort of get as you work with the language. But they're placeholders from the early days of programming languages because of memory references. It's essentially saying, if this variable doesn't actually refer to some place in memory to go get a value from, it's null. It doesn't have something to go get something from. And you talk about Java, you'll even run into it in Java, although it's not that common, where it might yell at you for a null pointer reference or something like that. All right, is everyone thoroughly confused about null and undefined at this point? Yeah? And let's just, we'll take the rest of class and we'll go over the new concept of while loops. And then,
Excuse me.
yeah.
Something happened. I don't know if that happened to you before. Okay, I try to.
Other people were saying, is it just Cloud9? Let me check. Other people have been having some problems with Cloud9 recently too.
I close.
Yeah, you can try and reopen it and see if
It's the same thing.
I had to shut down my computer and restart it to uninstall it.
Really. Let me check some things here. So there is an option in Cloud9. This is something I might suggest you try if you run into that. Let me see if I can show the whole class real fast. I'm not sure I'm logged in, so I don't know if this will work.
We're gonna have to use Cloud9 for any obligatory or mandatory assignments that relate to the class, or we can just set up our environments.
If you want to set it up on your own system, you can. The big benefits of Cloud9 are that everyone's using sort of the same environment, so we don't have to give as much split instruction of here's if you're on Windows, do this. If you're on Mac, do this. If you're on Linux, do this. And it's also relatively easy to share your code. So if you have a question or it's not working the way you want, it's pretty easy to share a workspace with us so that we can look at it and try and figure out what's going on. But other than that, if you prefer working in your own environment, you can do that because it's not hard to do. You can download Node. Let me make another note for that too. So yeah, you can install Node locally. What I was getting at here for the Cloud9 bits. So other people seem to have been having problems with this too. Let me check. Cloud9 CTD instructor. Put my password in. Other people have been running into some issues with their Cloud9 workspace getting hung up. One thing you might be able to do when that happens, instead of having to restart your whole computer, is in the menu up here, you've got this Cloud9 menu option. And one of the options down here is restart workspace. So if it's hanging, not letting you type something, I'd suggest trying this sort of restart workspace. Now this is huge. Like, now I got myself in a funky state because I'm too zoomed in. There we go. So that's an option for you to try that might like help solve that problem if you run into it. All right, so let's step into the other concept for today. We only really have, I would say, about 3 more major concepts to introduce before you can build a whole bunch of programs. 2 of them are relatively small. We've got this additional looping type control logic, and then we're going to introduce functions. Functions they're complex, but they're also somewhat easy to understand compared to the concept that builds on top of them, which are objects. And once we've introduced all of that, you'll have pretty much the major underpinnings. There's a few other types and items that we might introduce that make things easier to work with. But those are the major building blocks. So today we'll get through loops. We'll just do basic while loops, and then I might include some other types of examples in homework, or maybe add some other references. We may just add some other loops as we go through the rest of the class. But until now, you know, even with the if statements, all of our code is sort of moved sequentially through the program from top to bottom, like reading a book. Sure, sometimes you skip over a chunk of it with the if statement, but it's still going top to bottom. And when we introduce loops, now we're introducing the ability to sort of rerun sections of code again and again instead of just walking through directly. So I think we're just going to start with a very simple while loop example. We'll just put it up there and I'll walk through it real fast. And then we'll add some complexity as we go. A while loop, it looks a lot like a if block when you're declaring it. And the intention of calling it a while loop is it's supposed to almost read like English, like something you're saying. So if you were to read this line here for the start of the while loop, it sort of reads like, while the count is less than 10, do something. And that's exactly what the program's going to do when we run it. So when we run this code, it's going to run the code in that while block, reach the end of it, go back up to the top and check this expression in the parentheses to see if it's true or false. And if it's true, it's going to run the code in that while block a second time and just keep doing that over and over as long as that statement is true. In this case, it's pretty simple logic. It's just doing console.log, it's logging the count, and then incrementing it by 1 every time it runs through. Are there any questions about this simple while loop? Not right now? All right, well, did you notice a bug in the code that I have here for this while loop? At least a bug if we go by the comment that tells us what the code is supposed to be doing.
You got the output to line, right?
Yep.
Let's go. Just stop counting by zero.
What?
Does it start counting by zero?
I mean, we did. We can start counting at 1. Do you think that'll fix us? All right, so let's try that out. Let's start at 1 and see what happens. All right, looks like our bug is still there, which is fine. Anyone can explain why it's not giving us what we're looking for?
Because it's under 10, less than 10.
Because it's less than 10. Because if we walk through this, let's make this much smaller so that we can we can step through all of the times we go through it real fast, right? Let's say while our count is less than 2, spit out 1. And that's because it runs the code. It goes console.log 1, and then count equals 1 plus 1, which is 2. Now it goes back up to the top of this while loop, looks at it and says 2 is less than 2. That's false. So we're done. We kick out. So if we make this 3 instead and run it, we'll step through, we'll run this loop twice. So we're going to go, all right, count is 1, which is less than 3. That's true. So print 1, add 1 to 1. We have 2. Go back to the top. 2 is less than 3. That's true. So console.log 2. Then the count equals 2 plus 1, so 3. Go back to the top of the while loop. Is 3 less than 3? No. Spit out and don't run the while loop anymore. Go on beyond it. So if we wanted to fix this and actually count to 10, what could we do? Less than or equal to. Yeah. To type it in wrong. Will that work, we think? There we go. Because that last time it's 10, and 10 is less than or equal to 10, so it's true. So it runs through, spits it out, adds 1 to it, comes back up. Now it's 11, and it's not true anymore. All right. People sort of comfortable with that? I feel like it's not too hard, too complex. We'll definitely have a lot of assignments practicing sort of looping this way. And there's several other ways to write loops. I'm introducing just the while loop first. We'll introduce some of the other ones later, most likely. Because I feel like this is the easiest one to learn. Some of the other ones add more complexity to the looping process, but they make it easier to deal with the conditions and stuff of getting out of your loop. All right. So now let's write another one to show a common problem that people are going to encounter. Almost guarantee it when you're writing these loops is a while loop like this will continue to run through this loop as long as the expression that it's evaluating is true. So in this case, I just made the expression true directly instead of something more complex. Yeah?
I'm getting an unexpected question when I was trying to do it.
What I did? Just a moment and I'll take a look at it with you. Actually, let's look at it right now before we go through this one.
So I typed it all the exact same way and
You have a parentheses at the end of that line. Yep. A lot of times if you, by the way, when you're getting those sorts of messages in Cloud9, there's usually a little like exclamation mark or a red X over on the left-hand side where it's showing you the line numbers in your code. If you hover over that, it might even give you additional information about what exactly is wrong with the code. Sometimes they'll be like, hey, I don't know why this parenthesis is here. Or I don't know why. So it can be really helpful. There's a lot of tooling around that that's very smart to know what your code should and shouldn't do. Sometimes it doesn't solve it for you, but a lot of times it'll help out. So like I was saying, here's a common problem. You write a while loop and your condition never actually changes from true. It's always true. Which means it's just going to keep running and running and running and running forever. It's never going to break out of it. And if you end up in that case, it's the same as escaping out of other stuff. You do something like Control-C to just try and tell the program, hey, boot out. I know you're running, but get out of there. And we could make this a little more complex by, instead of doing this, let's do, because you're not likely to have just true in there. You're more likely to have written something wrong that you thought was correct. For example, Let me comment these lines out because I don't want to run those. Instead, I want to just console.log my count. Let's even increment it. So that we're going up because we think we're trying to match some condition, but we have our condition written wrong. So that's much more like what you're probably going to encounter at some point in your code. You're going to have a condition written wrong. Oh, I was actually checking if it was greater than 0 and never checking. And so that's always going to evaluate to true because I started at 1 and I'm adding numbers to it, which means just going to keep outputting forever. But yeah, Control C, other things, you can boot out of those without too much trouble. So let's introduce one more concept. Is you can break out of a loop other than at the while statement. There's another way to sort of step out of this loop, and that's by using a break statement. So let me make this one, let's do this one. I'll put break here. So this was a loop that would run forever because the condition is always true. But now that I put this break statement in there, which is another one of those reserved words, as soon as it hits that break statement, it kicks out of that loop. It's as if you went back to the top, evaluated it right then, and it said, nope, this is false, get out. So that's another way to exit a loop. And that works for any type of loop. And it exits it just sort of immediately, right at that line of code. So nothing, just to sort of prove that. You can even see it's yelling at me right now. But you can see this extra console log never runs. And it never runs because the loop exited immediately when it hit the break statement. Now, I would say, what good is a break statement for? Any guesses before we show some examples of what they're useful for? Why would you want to have another way to exit out of a loop besides the while at the top?
That keeps the system continually going and never even stopping other functions that might be after that.
Sure. Any other thoughts or guesses? I mean, that's a good point. So let's say we have a loop that instead of doing something very, very simple, like counting up, where we can always check that condition at the top, our loop does something a little more complex, and there's multiple paths or routes within the code that we want to check inside of it to decide if we want to stay in the loop or not. We're checking if somebody typed in a username or something within a certain number of times through it, or the character count is right and some other conditions or something like that. It might be nice as soon as you meet that condition to go ahead and exit out of the loop right then, instead of having to set some value that you have to run through the rest of the code in the loop and check against. And that's really where you would do a lot of this. So here's an example. Again, this one's very contrived, at least at first, but we'll build on it just a little bit in class here today. So this one is sort of just recreating what we've already done. Where we're counting up, except the while is always true. And it's only when our count is greater than 10 that we break out. And we have the break inside of this if statement, and it breaks out of our loop that we're in. So without this break, if we didn't have this here, this is another program that would run forever. And you have to have a little bit of patience with the control C when your program's running forever because it takes a while. Like I hit that and it took about 5 seconds before it quit running. But with the break, we kick out of the loop right here. Does that make sense? Is there anything in this code that doesn't make sense right now to somebody? I'd be surprised if there wasn't.
You use the break whenever you specifically want.
Yeah, whenever you specifically want to get out of the loop. Anybody looking at all of this code here and they don't see something strange? Good question. I put this in here because previously we wrote count equals count plus 1, right? If we wanted to increment the value. There's a common shorthand in pretty much all programming languages that says increment, add 1, and it's usually just putting a plus plus after the variable name. It's known as the increment operator. It's essentially shorthand for count equals count plus 1. Why would we do that? Because programmers are lazy. They don't like to type. Yeah. First lesson I learned from my college professor when I was learning computer science was a good programmer is a lazy programmer. If you don't have to do the work again, define it once so you can reuse that over and over and over forever is what he was trying to get at. Don't repeat yourself. Don't redo the same thing forever. Try and do it once. Try and shorten what you can do. This is an example of lazy programmers. Lazy programmers didn't want to type count equals count plus 1 all the time, so they put a plus plus on it instead as a way to do that. You also have the parallel minus minus, which is means subtract 1 from my value. So those are just shorthands. You know, if we were in Node, you could see it. Var count equals 0. Count plus plus plus. Count, you can see it's 1 now. Count plus plus. Count is 2. Good count minus minus. Count is 1. So it's just a shorthand notation for being lazy. But you can also see another great thing we're doing here is we're starting to build a program composed of the different pieces that we've learned about, right? Here we have a while loop of some kind, and then we also have an if block, a conditional, inside of it to do something. And I mean, that's sort of nifty. So maybe let's bring this back so it's a little closer to our example that we were doing before with, like, say, 42. So if all right. So sort of piecing together some of the stuff that we've been working with, starting to build a more complex program with some of this. Guesses on what the output of this program is?
So you not quite there yet.
Not quite there yet. Any other thoughts?
It's gonna say not quite there, and then it's gonna say that.
Oh.
Because it's too close to.
And I think if they loop, I mean, we would count until 41. 41 is less than 42, right? So you're never gonna get to be over 40.
All right, let's see what happens.
Wow.
But you had a break.
Yeah, I mean, so what it did, if we counted these lines, we should see like 42 lines that say not quite there yet as it's looping through this code. So we'll step through it. It goes, all right, we got 0. So while true, we're not 42, so we're not spitting that, but we are less than 42 because we're 0. So spit out not quite there yet. Add 1 to count, so now we're 1. Go back up. The while loop will always be true. We go through again. All right, we're still not 42, but 1 is less than 42, so not quite there yet. Add 1 to it, so we have 2. Go back to the top, we're in the while loop. Always true. We'll go through that until we get to 42, and then we'll, okay, now we've reached the answer to life, the universe, and everything, and we break, so we're out of the loop. So yeah, we should be impossible to ever get into the else statement here. However, if you're ever writing an if-else if, you always want to write an else statement for it. The alternative way we could have written this could have been 2 separate if blocks. But does that make sense to people? Yeah? Are we beginning to get a feel for how you can take these different pieces of programming and put them together to make a much more complex application? Like, we don't have a lot of complex bits of code now, but one of the assignments I'm going to give you will be, I'll have a tiny bit of code like we had in the last one where there was sort of a random number. So I'll have a little bit of line of code that'll get a random integer value. And then I'm gonna have you guys write the logic inside of a loop to try and guess the number. So we'll just make a number guessing game. The computer will choose a number and you'll try and guess what it is and match it and output whether or not you've matched it or not. And you can do that with just the little bits of building blocks that we have so far. You know, it's very, very similar to this program right here. That makes sense to everybody? Yeah?
If we like after count, you take off plus plus, those will be the same, or those will be required there. Yeah. Required there. Yeah. Like those we have before. If we take off plus plus.
If we take off the plus plus here?
Yeah.
If we just have that? What will happen? Yeah, we end up in a permanent loop because we're never changing the condition that we use to get out of the loop, right? That's one way to think about it. Think about what your condition, whenever you're writing a loop of some kind, think about what's my condition that I'm checking. In this case, the loop, it's a little tricky because the loop is checking true. which means, well, I have no condition. I'm directly checking that loop that's ever going to be false, right? But when you're writing looping code, think, what's the condition I'm checking? And how is that condition changing each time through the loop or changing in the loop somehow so that I can eventually exit this code? Because if you're not changing that value in some way, you're not making a change to it. In this case, we got rid of the change we were making, so count's never changing. And since that's the only thing we check against that will allow us to exit the loop, that means that the condition will never change. So whatever our initial state of that loop is, it's going to be the same. If it was false originally or whatever, well, it wouldn't have run. But if you got in that loop and you're never changing the condition for it, you're never going to get out of it. All right, people cool with that? I think that's where we're going to wrap it up for today. A little bit early, but not too bad. And then hopefully I'll be able to get a little bit more complex homework assignment, more repetition than the last one. How long did it take people for the last one? Was that about the right length? Would you prefer more examples, fewer examples, or fewer things to work through?
I would prefer to have more example before we have more like work.
Okay. I'll try and have the homework do some of that too, like be very small, simple things so they'll grow. It'll be like, start with this little piece, build on it, build on it, build on it, build on it. Awesome. Where's my, all right.